Thank you for coming to this session on serverless architecture. Before I launch into this, just want to take a few minutes to take an informal survey. How many people are JavaScript developers in here? Let's start with that. Okay. Java developers? Okay. Python? Okay. What have I missed? Who uses Perl still? Okay, one person. .NET, yes, sorry, .NET. Okay, we got some .NET folks in the house. Some .NET folks there. Great. So what I'm going to talk about in this session is actually agnostic to whatever programming platform is your preference, right? I'll do the examples in JavaScript just because it's a little bit easier than trying to fire up Java runtime or .NET CLR and blah, 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 whatever. So the code samples are fairly elementary, but what I hope to do in this session is to give you an idea of how building applications in serverless style architectures is different than the traditional architectures that you may be using today, which could be .NET on the CLR, Java on the JVM, Node, Python, whatever, right? So there's quite a bit of kind of dissonance between how you may be building applications today using any of those platforms versus how we build stuff in the serverless world, okay? So real quick, my name is Pratik Patel. I do all these things, and since I'm wearing the IBM t-shirt, you can probably guess I work at IBM as a developer advocate. And of course, for the one person who raised their hand about Perl, I think the Perl recovery group meets downstairs at the bar at 6 p.m. today, okay? So, all right, so and also, if you didn't know this, IBM is actually a huge contributor to open source in multiple different ways. So for example, Node-RED, if you're in the Node world, that's an IBM open source project, and there are tons and tons of open source IBM projects. IBM is probably one of the largest contributors to open source in whatever platform. All right. With that said, let's launch into serverless and talk about what is serverless first, look at architecture, and have a look at the ecosystem so that you have a better understanding of what you're facing when you start going down the road of serverless. Now, before I launch into this, how many people are building stuff using serverless tech today? Anybody? Okay. So what are y'all using? Start over here. Don't say AWS Lambda. Okay. AWS? Anyone using anything besides AWS Lambdas? No one's using Azure Cloud? Yeah. Azure Cloud Functions? Okay. How do you like Azure Cloud Functions? Yeah, okay. That's my opinion too. Not just because I'm wearing the shirt, okay? What's that? They have documentation problems? Okay. All right. So for those of you who already do know serverless, you may be bored for the first half of this, but bear with us, and we'll get to some of the more interesting parts a bit later. So the first thing about serverless is that, number one, it's a very bad name, okay? I don't know who comes up with names, but you probably know that what's the hardest problem in software programming? Naming things, exactly. So whoever came up with this name obviously was having a bad day, or maybe they were really badly hungover or something like that. But yes, there are still servers in the serverless world. Right, so there's a famous guy over at Google named Kelsey Hightower who's big in the containers and serverless space. And about a year ago, he tweeted this out. We asked 10 people to define serverless, we got 10,000 different answers. And this is true for any niche in technology, something that's like kind of just getting going or whatever. The developer community hasn't quite figured out all the ins and outs of it, right? So this is where we're kind of at in the serverless world. We're still getting a grasp on the terminology and what serverless tech actually means, even though it's about 4 to 5 years old now, right? But it's picking up momentum very quickly, especially in the last year. So anyways, this is social media, and you know what you expect on social media. So the responses to this were great. We asked developers to write one line of code. Instead, we got 10,000 containers, which is obviously a little bit of a dig at the whole Docker containers and Kubernetes, all that stuff, right? And then, of course, this is social media, so it gets weirder. Serverless is GeoCities for the enterprise. How many people remember GeoCities? Okay, so if you don't, this is what it looked like. Right? I actually found a GeoCities generator, and I was like, okay, I have to put this in now. So anyways, so yes, there are still servers, right? The idea, however, is that we remove the metaphor of the server from our developer mindset. We no longer think of servers, right? We just think of writing code, we push a magic button, and boom, our code is deployed somewhere and automatically scaled for us. That's the whole premise behind serverless. We don't worry about where that thing is deployed. And the nominal point behind serverless tech is that it's number one, cheaper, and number two, easier. We'll dive into both of these in a few minutes, right? So there are also some aliases for serverless technology. So when we use the word serverless, it's an umbrella term that refers to the style of computing and the metaphor around serverless, right? But what I'm going to refer to more specifically in this session is functions as a service, or FaaS, and cloud functions, right? So that's a part of serverless computing where we have the ability to write small blocks of code and have them deployed on some kind of serverless platform, right? So there's the overall terminology or term called serverless, which encompasses the computing style. So we can have serverless databases today as well, where you pay by the use or pay by usage, right? And there's like, no setup and all those other types of things. But we're going to look at specifically cloud functions in this session to give you an idea of how we build software around it, right? And if you want a formal definition, it's running code without provisioning or managing servers. And another way that I like to think of it is all the dev with none of the DevOps. Now, how many people in here do DevOps? Anybody? Okay, so the folks that just raised your hand, you may want to start learning something new, because in 2 or 3 years, DevOps will be totally automated by cloud providers and by artificial intelligence. So it's maybe time to start shifting into learning some of that stuff or whatever. And you'll see why I make that bold statement based on where tech is going, especially in serverless tech. Okay, so serverless takes care of scalability and availability for us. We give some code packaged up in a specific way to a serverless platform, and it goes and scales and makes sure our code is running somewhere. If we get a lot of hits to our APIs, it will scale it up to match the traffic. Once the traffic goes down, it scales it down. And one of the issues around serverless tech that we're still coming to grasp with as a community is the scale to zero problem, or often referred to as cold starts. Because the serverless platform provider may actually scale your application all the way down to 0 running instances, right? Because if you're not getting any traffic, why do they need to keep your code alive, right? Or your instance running your serverless cloud functions? We'll dive into that a little bit in a few minutes as well. Okay, so I said it was cheaper, right? So what does cheaper actually mean? Does anybody know how much it costs to spec out let's say an AWS mid-size, virtual server with 4 CPUs, 8 gigs of RAM? Does anyone know how much it costs today to do that? Yeah, how much? Oh, I thought someone raised their hand. All right, so it's about $200 to $250 a month. I don't remember exactly how much it is. But when you go and get that thing, when you go and get that virtual server and you go deploy your node application, or maybe you run it on a Kubernetes cluster, which costs even more because you're running a cluster, in the middle of the night at 3 a.m. when nobody's hitting your server, you're still paying for that server, right? You're renting that bit of equipment virtually, and you're paying for it all the time. The way that billing works in the serverless world is you pay only by the exact invocation and execution time of your code. So if you get 100 hits, and let's say that your serverless cloud function takes 300 milliseconds to run, right? The formula that we use, it's 300 milliseconds, nominally broken down into 100 millisecond time slices, times the amount of memory that your app uses, times some really, really small number, right? Actually, there are a couple more zeros in here, but I have space to fit it. And that's your cost. And that's how much you pay for one invocation. So if it gets hit 10,000 times in a day, you pay 10,000 times that number, okay? So it's the ultimate on-demand computing. You give it some code, the infrastructure manages how it scales it up and scales it down, and you pay only by the usage, okay? And at least with IBM Cloud Functions, they have a massive free tier where you get like 400 GMBPSs or whatever. They have specific nomenclature about it. So you can actually run a small to mid-size application on IBM Cloud Functions completely for free, right? They have a massive free tier. Once you go above that, this pricing algorithm kicks in and you pay only by the utilization, right? So we look at on-demand computing with something like serverless versus reserved computing, where you say, okay, I'm going to need an AWS mid-sized instance to go run my Node or Python or whatever application, right? Of course, you want to have high availability, so that 250 is actually 250 times 2, because you want to have 2 servers running in case one of them goes down or something like that, right? So that's how Amazon and these other cloud providers make so much money, because you're spending all this money on infrastructure, but you're paying for it all the time, right? All right, so talked about how, we'll get into how it's easier in just a minute, But let's look at serverless as an architectural model, right? Is it a new architectural model? Do we have to change the way that we think when we're building applications to be successful in a serverless-style environment? Right, so the analogy I like to use here is we made a massive leap in the mid to late 90s from microcomputing to software as a service, right? So if you were building in Delphi or Power Builder or Visual Basic back then, right, in the kind of mid to late 90s, you would write your code, and then how would you distribute your code to your users? Anybody? Yeah, exactly. You would literally get out a stack of floppy disks or a compact disk, you would burn the software onto there, and you would go to everybody's computer and manually install it. So with the rise of the internet, and especially the web, what we did then is we did software as a service. We would write some kind of servlets, or we would write CGI bin scripts, or whatever. And when we wanted to deploy a new version of our application, we would just tell the user, go refresh the web browser. And they had the latest version of our application. So we made a massive shift in the way that we distributed and thought about building software in the mid to late 90s, when we made that leap from the microcomputer era to the software as a service era. And in my opinion, we are at that point in terms of tech again. Right now, we think of things in terms of infrastructure as a service. Okay, I need to deploy this new application. I'm going to need 2 Amazon or IBM Cloud instances to go run this code. And then I'm going to need to set up an API gateway in front of it. And I'm going to need a load balancer and blah, 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 blah. So we set up all this infrastructure. But the mentality in our brain today is that we think in terms of infrastructure, rented infrastructure. We may own it, right, depending on which company you work at. Right? We may have in-house data centers that have some kind of infrastructure for us. But we think in terms of infrastructure. With serverless tech, what we do is we no longer think of infrastructure as something that we have to go and micromanage. We basically write some code, we push a button, and it's somebody else's problem to go and figure out how to scale it and load balance it and do all that stuff, right? So I like diagrams, so I put together this diagram, right? So today we have infrastructure at the bottom. We may use some kind of platform, typically some flavor of Linux, and all containers are all the rage now, so we'll package something up into a Docker container and then go and deploy it somehow. And then, of course, we have our app at the top of this pyramid, right? So where does serverless cloud functions fit into this specific architecture, right? So we still have apps at the top, but now we compose our apps built on functions, cloud functions, and there may be containers underneath it, but honestly, we don't really care, right? All that infrastructure is somebody else's job. It's the cloud provider's job to go and do that. Not our job to worry about it anymore. We hand over control to the cloud provider to go and manage that infrastructure for us, and what we do is we focus on writing code and delivering business value to our customers, right? So if we want to look at this from another angle, right, how many people were building software like in the early 2000s? There must be a few people in here, right? So I distinctly remember when I did a startup back in the early 2000s, we actually went and ordered a $8,000 Sun E4500 server to run our stuff on. It was bare metal, right? We didn't have virtualization at that time. So we actually ordered a server and we were working on bare metal. A few years later after that, VMware and the ability to do hyper-threading and other things like that took over. So now we were able to share a piece of physical equipment across multiple applications and get better utilization out of it. And then, of course, with the rise of AWS and the cloud, we moved into the era of cloud and containers, which is where we are currently. And where we're headed right now is this era of cloud functions. Okay? Anyways, I like diagrams, so I throw some in here or there. All right, so in terms of a new architecture, we focus on building applications. Docker, what's Docker? Who cares? You write your application, you give it to the serverless platform, and they go run it for you. Right? They may package it up as a Docker container. In fact, the demo that I'm going to do today using Apache OpenWhisk and IBM Cloud Functions, they use Docker containers underneath the hood, but I never see them unless I want to. Right? So in terms of how we build applications, this is where I want to take a little bit of a deep dive. Right? So we will write our own cloud functions to build an application, but we will also use existing cloud functions, whether they're written by me or by somebody in my company or a third party. Right? So what we do is we weave together and build full applications, not at the low library level anymore. We think at a higher level in terms of building using composable cloud functions, right? And I'll go into that a little bit in just a second. The other thing around cloud functions is that we typically also think of them in an event-driven style architecture, right? So most of you in this room have probably worked in some kind of event-driven architecture, whether it's Java Message Service, maybe using RabbitMQ, whatever, right? Eventing is all around us in the software industry because it's a proven pattern for building scalable applications that are loosely coupled. So at the core of almost every good serverless platform is the ability to do eventing and to decouple our cloud functions and be able to wire them together using different types of eventing, depending on what we're trying to do, right? So when we think of events, anything can be modeled in our brain as an event. The classic one is we have a message queue, we pull an event off a message queue, it goes and fires a cloud function. An HTTP call, we also consider to be an event. Incoming email, we go and trigger a cloud function to go and do something, a file system or database monitor, someone does an insertion into a database, it goes and triggers a cloud function as an event, okay? So we build the way we think around, the way we build software is we adjust our thinking to be event-driven and be able to be scalable using an event-driven style architecture, right? So that anything can be modeled as an event in software. In a lot of ways, we've been doing this for quite some time, right? Eventing is nothing new. Containers and basically wrapping code inside of a layer underneath, doing some abstraction, that's not new. So in a lot of ways, the serverless revolution, in my opinion, is more of an evolution. We're taking all these things that we've learned over the last decade or two, and we're bringing it together so that we're able to better utilize the most important thing that we have, which is our brain power. We don't want to waste time working on these ancillary things and setting up Docker containers and going and configuring a Kubernetes cluster. We want to write code and deliver features to our customers, right? So I don't call the serverless revolution a revolution. I call it more an evolution of all the different things we've been doing for years, right? And again, you might already be using some style of serverless computing. If you use Twilio for SMS, you don't use a library for Twilio, right? What do? You make some kind of event call to a Twilio service to send an SMS, for example, right? So if you're using, for example, Google image services, right? You can go and resize an image by basically saying, here's an image, right? You hit some kind of HTTP endpoint, and it gives you back some image that's been, machine modified in some way or whatever, right? If you use Stripe for payments, et cetera, the list goes on and on. But this is the primary shift that we have to make in terms of developers, or changing our developer mindset. Today what we do is say you want to do OCR in your project, optical character recognition. What do? You go and grab an OCR library, you include it in your project. Now your project has gotten bigger, right? And then you, depending on which language you're in, you'll say OCR library lib equals, new OCR lib, and then you go and make some low level calls to go and hit that OCR library or whatever, right? Think of any library that you've used in the past month or year or whatever, right? Today we think about including a library in a project, and we go directly invoke it inside of the runtime that the rest of our code is running it. When we move into serverless style of software development, what we want to do mentally is we want to think of firing an event with parameters to invoke a cloud function or a function as a service. So we're no longer building and composing applications down here at the low code and library level. We're composing applications up here at the higher abstraction, more granular way of building software, okay? So we basically take these libraries, we may wrap them into a cloud function to get that functionality, but we do coupling and integration at a much higher level as opposed to the library level. So this is the biggest shift I had to make when I started to work and build projects out with serverless style computing, AKA cloud functions, okay? So any questions on this before we move on? This is probably the key takeaway of this session, is understanding how we have to shift our thinking a little bit to be able to make that leap in terms of being successful at building serverless style cloud functions. Okay. Anybody? No? All right. So a couple of things around this is our cloud functions need to be small. They should be quote unquote a unit of work. And they should also be single purpose. You can have cloud functions that do multiple things. That's okay, right? But you have to be a little bit smart about it and not go and put too much. You can't. We don't think in terms of microservices, right? How many people are doing microservices today? Out of curiosity. Okay, so a few folks, right? So you're probably familiar with all the stuff that's been going on in the microservices world. And for me, cloud functions are the tip of that microservices pyramid, right? And don't tweet this, but I almost think of them as being nanoservices as opposed to microservices, right? We're making things smaller and smaller so that we can get composability and get more flexibility out of our architecture. So single purpose and a small unit of work, okay? The other thing around cloud functions is they should be short running and they are typically going to be stateless. Now, short running is important here because how do we pay for cloud functions? We pay by the amount of CPU time that execution actually takes. We want it to be small. Right? The other reason we want it to be small is because of what's known as the cold start problem. Our infrastructure provider, our cloud function provider may scale everything down to 0. So the first time a user comes in, when we've been scaled to 0, it will take a little bit of time for our application to start. So we want our application to start very quickly so that the user doesn't have a bad user experience, right? So, you scale from 0 to 1 to 5, and every time an instance starts up, it takes a little bit of time for it to fire up. And typically a cloud function provider will keep your instance alive anywhere from 5 to 10 minutes before scaling it down once it detects that there's no more additional traffic coming in. So it's not a case that everything just scales down to 0 immediately. Right, so if your cloud function provider like IBM Cloud Functions scales up to, let's say, 10 concurrent instances of a specific cloud function, they will be alive for 5 or 10 minutes. It's not going to get completely destroyed. But again, we want to keep our things small, our cloud functions small, so that they start up quickly and also they run very quickly. So the other thing around cloud functions is they're typically also stateless. Now this is a problem if you're used to working in a standard whatever. Python on Django, Ruby on Rails, right? Node. Because when you build web applications today on the server side, you typically create in any of those environments some kind of session object that stores the user's information temporarily while they're browsing or doing whatever on your website. Because you don't want to make your user log in every time they do something, right? You make the user log in once, and then the session expires after 10 or 20 or 30 minutes or whatever, right? But that state is kept in the application server. Again, it doesn't matter which platform you're running on, right? So serverless cloud functions are inherently stateless. So how do we work in a stateful manner, or how do we build an application that needs to be stateful and something that is inherently stateless, right? So there are a couple of different ways that we can tackle this problem in the serverless world. What I typically do is I have an in-memory data grid like Redis that sits beneath my cloud functions layer. And whenever I need to go get session data, I just reach into that, I look at the cookie that's coming in, I reach into my Redis, I go grab whatever data is associated with that cookie, i.e. the user, and then I go and hydrate that data inside of my cloud function and go do whatever stuff I need to do. Okay, so there are ways that we work with this, but cloud functions are inherently stateless. Okay, and that's a tripping point for some people. And additionally, cloud functions can be invoked synchronously or asynchronously. So you can make a call to a cloud function and say, go and run this, I want the results immediately. Or you can say, here's some parameters, go and run this cloud function, I'll be back later to get the results. Okay? So it gives us flexibility in terms of the way that we architect our application. All right? So async is useful for a good number of use cases. It can be useful for long-running code. Say that you're generating a PDF, and it may take 30 seconds or a minute. You don't necessarily want to keep an HTTP connection open for that whole time. So you can just say, I'll be back later for it. So whenever you invoke a cloud function, whether it's synchronous or asynchronous, you get something back like an ID, or typically what we call it is an activation ID. And that activation ID will be alive for X number of minutes so that you can go back and say, okay, I'm ready for that thing. Here's the ID, activation ID, give me the results. And you'll get the results back. And you can call that multiple times, which is also very interesting and can be useful in certain cases. Okay? So we've gone over the basic fundamentals of architecture in a serverless world. We've looked at like overall what serverless means. Let's look at some cloud functions and do a quick demo. I don't know how much time I got. Ooh, I have 20 minutes. That's good. So one thing to note is that you can write your cloud functions with all the different things that I talked about before, but you can invoke them with anything, right? So you can write a Node cloud function, and then you can invoke it from a web browser or from a Java application or from a Python app or whatever, okay? You can invoke a cloud function in any specific way. So what we're going to do a demo of in this session is we're going to look at Apache OpenWhisk, which is an open source project out of the Apache Foundation. And it is one of the oldest implementations of cloud functions that has been around. And of course, everyone has also heard of Amazon Lambda, which Amazon Lambda were the first people to go and do cloud functions. But we're not going to look at that because that's boring. So one thing I want to cover very quickly here is we talked about the arc in terms of like where we've been and how we've gotten to where we are today, right? We talked about bare metal, we talked about virtualization, we talked about containers, etc. And so there's a guy out of the UK, his name is Simon Wardley. He does these things called Wardley maps, and they're useful for organizing your thinking. This is one of his, right? So when we think of how we build a project, right? How we go and build a project and how that project matures over time, right? So we have the inception of the project, the genesis. We typically will do a custom build. We build a product around that project. And at some point, we need to do service rental around that project, right? The service and rental means we have to deploy it somewhere on the cloud. So we'll go rent some compute power, i.e. a AWS or IBM cloud instance of some kind, right? But at some point in time, we want to consider that we want to move from a product to more a service utility type of mentality around that specific product that we've been building. And also over time is that we eventually end up at a point where we run that project and how we deploy it and how we pay for it becomes less of a product feature and more of a commodity, okay? So we're getting into some economics here. Do we have any econ majors in here? Okay, a few. All right. So I don't want to use too much economic vernacular here, but the point here is that over time, things get commoditized, and this is what's happening in tech in general. So we think of a product over time becoming commoditized, right, because of competition and other things in the marketplace. Now, if we apply that same kind of logic to what's happening in the compute world, right, we used to run software on our servers under our desks, and then they went to a data center, and then they moved into some magical thing called the cloud. And so what's happening is we're fastly approaching that point where compute power is becoming commoditized. And if we're paying too much for compute power, right, what happens is that the competition can leave us behind, right? Because they've already moved into the commodity part where they're using serverless style architecture and they're deploying stuff on an on-demand basis or having on-demand execution, on-demand pricing around everything. So they're paying way, way less than what you may be paying in your company, right? We're talking about you and your competition. So this is a good time to talk about a study that was done a little while ago. Everyone's heard of Expedia, I assume, right? The online travel booking portal. So they made a shift for part of their infrastructure to serverless computing. So before, they were paying somewhere between $5 and $6 million a month. It's Expedia, right? $5 and $6 million a month for essentially AWS instances, right? And obviously they had engineering staff that had to go manage all those instances and keep everything up and configured and up to date, et cetera, et cetera. So they made a switch about 3 years ago, I think, to serverless style architecture and serverless style computing. They cut that $5 to $6 million a month down to $500,000 to $700,000 a month. And I don't know about you, but that's a lot of money, right? So again, when we think in terms of businesses and or our business or our company's business and how we want to approach that long term, being invested in serverless technology and understanding it at least is something I feel is very important, okay? So the other thing I like to say at this point is that when I did my first startup in the early 2000s, we had to spend a lot of money just to buy hardware, right? We bought a Sun like E3500 or 4500, cost like $8,000. It's never been a better time to do a software startup than today. You can literally get started for free And the only thing that you have, the only price that you have to pay is your own time and your own brain power to take a concept to market. You can literally go from zero to market without having to spend any real money, which is amazing, I think. I wish I had that back then. All right, so time for some live coding. And may the demo gods be good to us today. All right. So, oops, that's not the right one. John, you may recognize this. So John is the creator of Unified Library, so he's sitting up front. All right, let's go serverless JavaScript. All right, let's make this a little bit bigger. All right, get rid of this. All right, so the way that we write a cloud function, and this is specifically using Apache OpenWhisk, which is an open source project, which you can actually install on your own laptop, right? So you don't have to deploy to the cloud to run these demos, but it takes a little while to install OpenWhisk and get everything configured correctly. So it's actually easier just to use IBM Cloud Functions, which is hosted Apache OpenWhisk, right? So the input and output for a cloud function is really straightforward. The input would be just a JavaScript object. In this case, I've called it params. We have to name that function main. And then what we do, as you can see, is we go do some stuff. We can go grab some stuff out of the params. And then we return a JSON object. So it's JSON in and JSON out. That is essentially the API or the interface or whatever you want to call it for a standard cloud function. Okay. So I have a couple here. We can also do something called web-based cloud functions where we indicate to the platform that we're not going to be returning JSON, we're going to be returning HTML. So we have a specific signature we have to follow in the return to be able to do that. Okay, but it's relatively straightforward. Let's go and actually invoke this. So I have my Cloud Functions CLI open here, or my UI open here. And you can see I have Cloud Functions in a number of different languages here. Let's go find the one I just had open. Okay, so here we go. Hello JavaScript. And one of the nice things with, at least with IBM Cloud Functions, is please work. There, it worked, okay. All right, so let's scroll down. Where's my output? There it is, right? So hello from user, location, earth, etc. Okay, so one of the nice things about, at least with IBM Cloud Functions, is I can actually go into here and directly type some code. Hello, and which conference are we at? Refactr.tech. Save it, and I can go invoke it, and you'll see that here is my output, right? So this is kind of nice. You can do some quick prototyping or just some experimentation directly from the web interface, which is kind of nice, okay? And it's also handy for troubleshooting. Now, one thing I talked about earlier is the cold start problem. So let's go and find an action that I have not fired up yet, okay? I'm going to pick on this Java action for now. So you can't see the code because, unfortunately, Java is not a scripting language, so there's not a code console that you can do that from. Same thing with .NET, because it's a compiled language and not a scripting language, you can't go and edit the code. But let's go run this example. This is basically going and creating an entry in a NoSQL database that's also running in the cloud, right? And if you watch up here in the top right corner, well, let me zoom in here, right? So let's see how long this takes. I hope it works. Otherwise, this will be a really bad demo. This is taking a long time to fire up. It may not even work, actually. Let's see what the hell's going on. Okay, well, we have to wait for the, hey, it finally worked. Okay, so remember, before I was talking about the cold start problem. In this specific Java project, because of the way I constructed it, it took a long time for the Java virtual machine to start up, load all the database drivers, et cetera, et cetera, et cetera, right? It's actually not a lot of code, maybe 20 lines of code or so. But you saw it took 20 seconds or so to fire up. And then the invocation time itself was about 1 second. Now, what happens if I go and run this again? Okay, let's scroll. Yes, it will be faster. At least we hope so. Okay, so let's clear this. Let's go invoke it. And you can see that it ran in 100 some milliseconds this time because it's not cold anymore. It's warm, right? So depending on what you're doing or which platform you choose, you have to figure out a way to ameliorate this situation. Because you can't have this cold start, right? You don't want to penalize your user 20 seconds just because your app is scaled to 0. And there are patterns and ways to go and do this. One thing that folks do is, especially for AWS Lambdas, is they run a process over here that just goes and pings their cloud functions every minute or two, right? They pay for that, but it just does a ping and it keeps them warm, right? But that's not what we want to do. That feels very hacky. right? And also costs us money. So, for example, what we can do in the Java world, at least, right? And this would be true for the .NET world, which is also, or if you're using actually Swift compiles down to binary. So let me go find another project here. I think this one should start really fast, but let's find out. Okay, maybe not that one. Okay, it took a second to start up, but if you notice here, okay, if you notice here, I have a number of different projects, right? Some are Java, some are Node, but there's also this thing called Docker. So with Apache OpenWhisk, you also have the ability to say, you know what, I just want to wrap a binary into a Docker container, and then you can go run it for me. So that's what I did in this case, is I basically used Java, produced a binary call from a technology called GraalVM or Substrate VM that instead of running inside of a Java virtual machine, it goes and produces a binary that starts up instantly, right? It makes some compromises along the way. It basically removes AOT and reflection and other features in Java. But I'm able to package that as a Docker container and say, here you go, OpenWhisk. This is my cloud function. I want to package it up as a Docker container. I have a colleague based out of the United Kingdom. He has a really nice demo around machine learning and serverless. And what he does is he has a TensorFlow Python-based project. And the model for that, the TensorFlow model for that specific AI ML project is about 200 or 300 megs in size. So what he did is he packaged up Python and all the TensorFlow libs and the TensorFlow data set into a Docker container and gave it to OpenWhisk and said, here, go run this. And the point of telling you that story is that it gives you an immense amount of flexibility and is really useful for certain situations which you may consider to be edge cases when you're coming and building stuff in a serverless style. Okay? All right, so let's have a look at a couple more examples real quick and see what I got open. Okay, so let's actually pull up something a little bit more interesting. If I can find it. I had it open. Okay. Let's just go here. Open. Okay, I think I want to do the this one. Okay. So let's look at more of a real world application instead of just a stupidly simple hello world. Okay. So what I'm working on right now is basically a project which allows you to run a free blog. So it uses Vue.js and Vuetify on the front, and it uses Cloud Functions on the back. And again, because IBM Cloud Functions has such a huge free tier, like I could get like 10,000 hits a day to this blog or more, and it would still be completely free. Okay, but let's look at some of the code to give you an idea of how this is architected. Okay, so let's go into, so you can see here, I have my standard CRUD type operations, create, update, delete. So let's go look at save post. Okay, and what I'm doing is I'm using a CloudAnt database, which is essentially a CouchDB-based NoSQL database that also has a free tier, right? So everything is free. Right? And so here's my document object, JSON object. Here's my main, my params. I have this DB name here as an extra param. I can talk about that in a minute if we have a little bit of time. And here's a promise. So I'm using a promises-based library here, specifically in CloudAnt, in this CloudAnt driver, database driver. It allows you to use promises as a way of constructing, because JavaScript is asynchronous, right? So I say go and connect to CloudAnt, create some CloudAnt credentials, and connect to the CloudAnt database. Go use this specific database if it is named. Do database.insert. And then I have a then and a resolve. If it's successful, we return content type, application, JSON, blah, blah, blah. We basically go and return whichever document we stored in here. And you can see what the document is, right? Well, let me zoom in a little bit. It's a little small. Okay, all right. So you can see it's the standard things that we would need to have for a blog. What's the ID, author, title, is there an image, what are the tags, is it published, and the body, et cetera, right? Standard blog type of thing. But this is how I go and insert, using a serverless cloud function, this is how I go and insert this into a database to go get later. And of course, I'm using a promise here, so in case there's some kind of error, I have to be mindful of that and go and return the error and wrap it inside of 500 error code, et cetera, right? Relatively straightforward, kind of resty stuff here. And if we go and look at get post, similar kind of thing, go and initialize my Cloud Ant database, use a new promise because JavaScript is asynchronous, go and database, get me a list, descending through, include the whole document, limit, skip, et cetera, for pagination. And then I say go and get me that stuff, and of course I have to do some error handling, and if everything works good, we go and send back, where is it gone here? And so we go and send the body back here, or if we're just going and getting a single thing, if we're not doing a list, again, go and do all this stuff and return the fetched data from the database, right? So you can see I have a promise inside of it. I have a callback style thing inside of another callback, again, because this is JavaScript, okay? So just to give you a quick idea of what this looks like, and of course, if we wanted to, I could go run this from the console, if I can find it. It's here somewhere. Right, here it is, right, blog JavaScript. So that was my get posts, and that's the exact code we were just looking at. Let's go invoke that. And you can see that took about 424 milliseconds. Oops, the first time I ran it, right? And you can see here's my test data, author, body, image, blah, blah, blah. Now if I go run this again, what does this look like? Right, you can see it took 32 seconds the second time because that node instance was fired up. And if I scroll down, you'll see the first time it took about half a second, or 400 milliseconds, okay? All right, so just a quick flyby, give you an idea of what the code looks like. So let's wrap this up since we have a couple minutes. Is there lunch directly after this? No? Oh, I can go on and on then. So I have a rule that to get really good speaker ratings, if your session is before lunch, always end early. I don't know why that works, but anyways. Okay, so with OpenWhisk, you can build on any of these different platforms, but as I explained earlier, you can actually just give it a Docker image. So you can build with anything, right? As long as you can package it up into a Docker image, you can deploy it onto Apache OpenWhisk. And of course, these are all the standard things that are supported out of the box. We call those things actions in OpenWhisk. Yes, sir. Yeah. 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 So but all you do is you basically the interface for building a OpenWhisk compliant Docker container is you need to have two endpoints. You need to expose 8080 as a HTTP, and you need to have a /init endpoint and a /run endpoint. You can probably guess what they do. The init is if you need to do some initialization before you can hit the run, you go put stuff there, and then the /run is where you just put like your code, right? So it's really that simple. Yeah. All right. So there's these things, and so I just want to close out quickly and say all this sounds great, right? At least I hope it does, right? But we have to think about a few things, right? There are some edge cases around. How is it that we go about taking what we have currently built, or if we're working on a greenfield project, how do we think about, is jumping into the serverless pool what we want to do? Now, there are some edge cases around serverless computing. In my opinion, I would say that 80 to 90% of what everybody in this room does is capable and actually would work very well in a serverless style architecture. But there is about a 10 to 20% edge case scenario. So one of those edge cases is that if you're very heavy on compute, like say you're running algorithms, like you're working fintech, you're mining Bitcoin. I'm kidding about the Bitcoin. So that is probably not well suited for a serverless style architecture. In that case, you just want a dedicated server farm going and running your computations or your algorithms or whatever, okay? So there's certain things that I think you have to watch out for, but if you're just building a standard application where you go reach into a database, you get some data, you do some stuff with it, and then you go return it, right? That's most applications anyways, right? Or at least feels like it. That is very well suited for this style of architecture. Now, one thing I should note real quick, let me see if I can find it. I do want to point this out real quick, is on my GitHub page, I have a full day workshop and also where's the mini workshop? It's got to be here. Oh, there it is. Right. So if you're either in the JavaScript or Java world, I have a 3-hour JavaScript mini workshop that walks you through all this stuff. So when you're sitting at home on a Sunday night, you can pour yourself a glass of wine, open up this GitHub repo, and just start working through all this. That's what you do on a Saturday night, right? Like you basically code, right? Yeah, okay. So yeah, so I have everything in here with detailed instructions, and of course, if you get stuck, you can hit me up on Twitter because I'll probably be coding on Saturday night too. And this walks you through building all this stuff. And the other tutorial that I'm releasing soon is the I can show you actually is it's the free blog thing, free blog engine, right? Has anybody heard of what's happening over at Medium? Maybe some of you have been following along with their change in policy. Anyways, I pulled all my stuff from Medium, and I just decided, I was like, oh, I'll build this all serverless. This would be 100% free. The static content is hosted on GitHub Pages, and with GitHub Pages, you can have a personalized URL like that. But this backend is actually going and hitting some of the code that I was showing earlier with the blog posts, right? So you can run all that stuff for free and have your own free blog up on the internet using this. But anyways, the point here is that you can find all this fun stuff on my GitHub page, and it's the same as my Twitter handle. It's just PR Patel. Okay. All right. So let's close this out real quick. All right. So a couple of things in closing. All right. So yes, there are some edge cases that we need to be aware of, but in a lot of ways, the cost of the utility commoditized computing that we're referring to here is sometimes the least of my concerns. What I really care about when I'm working on a product, right, and working on a team of people who are building a product, the execution cost is often, the execution cost being how much does it cost to run my software in the cloud. That is sometimes the least of my concerns. What I care about more, number one, is time to market, right? Because since I don't have to worry about infrastructure now, since I don't have to dedicate half of one person's resource to going and speccing out these servers and setting up a load balancer and going and babysitting all that crap all the time, I can have that person's half time now working on product. I get faster time to market. Plus, with all the tools I have, I basically write code, push a button, and boom, it just appears. There's very little overhead, and there's a term that some people use called ceremony, right? We're slowly evolving to a place in the software development world where we're realizing that we don't want to have a lot of ceremony. We don't want to write a lot of code. We want to discard that ceremony and focus on what we're trying to do. That helps with my time to market. The other thing around this is that it's the cost of development, which is often massive, right? How much does an average software developer make in Atlanta today? $80,000, $100,000, right? Now that I've been able to take that half a person's time and apply that, I'll just save my company $40,000 or $50,000, right? So anyways, for those of you who raised your hand about working in DevOps, this is why, right? We're going to be able to automate all this stuff. It's Google's problem or Amazon's problem or IBM Cloud's problem to deal with the infrastructure and manage all that stuff for you. You write code, you ship it. They have smart people that will use AI and other techniques to make the software run for you in the way that you expect. All right, and I'm over time now, so I'll shut up now. Only 3 minutes over time, good. So if you have any questions, you're welcome to ping me on Twitter. How many people are local to Atlanta real quick? Okay, so I live here in the ATL. If you would like for me to come and lead your company in one of these half-day or full-day workshops, just let me know. That's my job to come and help you and learn this tech. And how many people are not from Atlanta real quick? Right, so even if you're not from Atlanta, we get on airplanes frequently as developer advocates, so I can come see you at your, wherever, your meetup, if you run a meetup, or your company, if you're interested in doing a hands-on workshop, whether it's in JavaScript, Java, we have Python as well, and we also have Swift and Go, so we can cover all the languages depending on what you're interested in. So anyways, I will shut up now. I'll let you get going to the next session. Thank you for coming, and please reach out to me on Twitter if you want to follow up.